Hi, today I will be solving valid parentheses. The problem reads, given a string S containing just the characters shown here, each of the open and closing parentheses type, determine if the input string is valid. An input string is valid if open bracket is closed by the same type of bracket, and open brackets are closed in the correct order. So in determining the validity of an input string, two things are of emphasis. That is the type of brackets and the order. Now let's take a look at the examples. The first example and the third example address the first clause, which is open and closed brackets should be of the same type. So in example 1, we see that's the case. They're of the same type, opening and closing, so it renders it true. It's a valid string. However, number 3 opens with one type with round parentheses and closes with a square bracket. That makes it false, so it's an invalid string. Number 2 abides by both the first and second clause, so it opens and closes with the same type of bracket, and they're in the correct order, so that makes it true. In contrast, number 4 violates both the type and order rule, as can be seen here. We open with a round parentheses and close with a bracket, and that messes up the order, the coordination of our parentheses. So in place of, so when we see a round parentheses opening, we expect a round closing parentheses, which is not occurring in this case. Similarly, when I open with a square bracket inside, I expect a square bracket inside, not a round one. So that makes it false. The final one, however, abides by both the rules. So it opens and closes with the same type of bracket, and it's in the correct order as well. So that's true. Now this question is very, very relevant in terms of the tech interview questions. A lot of companies ask this question of their candidates, and some of the companies that do ask this include Bloomberg, Amazon, Facebook, Microsoft, Apple, Google, IBM, and many more companies. So that makes it relevant. And another interesting fact is that code editors, when they compile the code syntax, they have to validate parentheses, and they use the very algorithm which I'm going to be discussing and showing how to write. So it makes it all the more relevant. So I have my algorithm written out over here, and I came to think of this problem as a quintessential stack problem. So we're dealing with the input, which is a string, and my intuition was that, okay, so there's a string and there are different elements, and those elements consist of parentheses, and to validate those parentheses, I have to look at them one at a time, and I will not know what's inside, what the nested parentheses might be if they're nested, or what the parentheses are in the center. So I figured that I'll have to traverse the parentheses from left, going basically from outwards to inwards to access the whole of it. I would have to go in the direction of outwards to inwards. So I figured that a stack would be a good use case for this problem, because stack has a LIFO operation, which basically means that last in, first out. So if you want to imagine a stack of plates or books, so you stack 1, 2, 3 items. So the last item that you stack is the first one that is accessible, and that's what's implied by the acronym LIFO, last in, first out. So whatever you stacked at the top is the last thing that you stacked on your stack, and that is the first one you can take out. So that feature of it lends itself really well with this problem, though I want to acknowledge that there are definitely alternatives to solving this problem, namely using counter or even a hash map. Should you want me to address those alternatives, comment below. I'll be happy to take a look at those and provide the solutions and explanations as well. Anyhow, let me just briefly summarize the algorithm conceptually, and then I'll do a code walkthrough and explain step by step with my input example here on the right side. So I'm using an arrow function syntax, and S is my parameter, which is basically my input string consisting of the parentheses, and this whole function is referenced by my isValid variable. And I will be initializing a stack data structure, and I called it so stack over here. Utilizing a for loop, I intend to traverse my input string of parentheses from left to right, one element at a time, so one parentheses at a time. Now, I have three scenarios conceptually that I want to address here, that this algorithm addresses, which is if s of I, that is the current element, if that happens to be any one of these opening brackets, and this is what the double bar notion is, it means or. So if my current element is this parentheses or this, then I'm going to push it to the stack. That's my basic idea initially. See an opening parentheses of any kind, push it to the stack. The next scenario in our input string is, if it's not an opening parentheses, we expect a closing parentheses, and that's where the else come in. So whenever I come in else, automatically it means I have encountered a closing parentheses, and closing parentheses are right here. So what I do as soon as I come into else is that I remove the first element, the top element in my stack. So what is the top element in the stack again? It's the last one that was inserted into the stack, right? LIFO, remember? So whatever I last inserted into my stack will be the first one that I can remove. And that's what the variable last has reference to. The element at the top of my stack is referenced in this variable last. So whenever I use last, it's basically holding the element at the top of my stack. Now going into the else condition, like I said, is when we have a closing parentheses, what we want to check is that the closing parentheses has a corresponding opening parentheses at the top of the stack. If and only if this happens, it means we have a valid parentheses. If that doesn't happen, which is denoted by here, if the combination that I just mentioned, if that does not take place, then we can assume that our parentheses is invalid. And we would immediately pronounce the set of parentheses as false. We don't have to further look for other possible valid parentheses within the sub input string or the remaining part of the string. It would immediately disqualify as being a valid parentheses upon seeing even one instance of this case not meeting. What is the case again? Every closing parentheses shall have its corresponding opening parentheses at the top of stack. If and only if this happens can we pronounce the parentheses to be valid. If that doesn't happen, it's going to be called off as invalid, and this is what the not is denoting again. We return false. So that is the second concept. It's very important. That's why we have this and. It's a combinational event. So see a closing, we expect to see at the top of the stack its corresponding opening parentheses. So here ends my if condition with this curly brace, and then here ends my else condition with this curly brace. Now outside of my for loop, I have this condition if stack.length is not equal to 0. What that means is if after having traversed my input string, I see that the stack still has an opening parentheses, and remember, stack only holds the opening parentheses. So if the length is not 0, that means there is one or more parentheses still remaining in my stack. Well, that indicates my input string is invalid, because for the overall string to be valid, there needs to be even number of parentheses. What that would mean is each parentheses has been accounted by its corresponding closing parentheses. If that doesn't happen, that invalidates the parentheses, because there is something remaining. There's an opening, a bracket, a parentheses remaining, which has not been accounted for, and that would render it false. So if our stack is empty and we pushed all of our opening parentheses onto the stack, and we also found all the closing parentheses, and we found its corresponding opening parentheses at the top of the stack, and our stack is empty finally, then we're all good. We just return true. But if we don't find, for for every closing parentheses it's opening parentheses, then opening parentheses at the top of the stack, then it's false. And also if after having traversed the whole input string we see some remnant opening parentheses in the stack, that would render it false as well. So I just want to reiterate that, keep that in mind. So if we traverse and we find opening parentheses, we push it to the stack, and closing parentheses, we see its corresponding opening parentheses, and the stack is not empty, that is the situation that we want, which renders it true, valid parentheses. Otherwise, it's false. Now let's walk through an input example so to solidify the understanding. So I have this input string here, so let's walk through. So starting off, I equals to 0 here. So when I equals to 0, that is when we are at index 0, s of I, our current element, is a round parentheses opening. Again, what do we do when we encounter opening parentheses? When s of I is any one of these opening parentheses, we push it onto the stack, like so. Now index is 1, and s of I is now square bracket. Again, it's an opening bracket of another kind, so we push it onto the stack. Now what do we see? So when index is 2, we see a closing bracket. So when we see a closing bracket, we come to the else condition, and we remove the topmost element in our stack, and the topmost element in the stack is a opening square bracket. So I'm going to scribble it off, just consider it being popped off. Okay, so I just popped it off accordingly. So then when s of I is a closing parentheses, which it is, round closing parentheses, then I expect the top of my stack to be a opening, when s of I is a closing square bracket, which it is, right? Our index 2 we're at, it's a closing square bracket. I expect the top of my stack to be a opening square bracket. That is, the top of my stack should be corresponding parentheses type of my closing parentheses, which it is, right? Square closing corresponds to square opening, which I had found, so that's what. So I removed it from my stack. So that's good. Now we proceed to the next element. So at index 3, which is our final index in our input example, we see a round closing parentheses. So again, we go into the else condition and we pop off the topmost element in our stack. So since we have already popped off the previous top, now our current top would be this element right here, the round opening parentheses. So let's pop that off, and remember, I'm scribbling it off, just consider it being popped off for the sake of our explanation here. So we popped off our corresponding opening parentheses to our closing parentheses here. So now we don't have any other elements to traverse. We found matching pairs of parentheses for all our opening parentheses, and the stack is empty. As you can see, I've scribbled off the only 2 contents that were there, and we simply return true, and we're done. So it's as simple as that. You can try any combination of parentheses and see and run through the code just like I did, and hopefully that would better facilitate a understanding. So for the space and complexity analysis, the time would be O of n time complexity, because we're traversing one character at a time, and the push and pop operations on a stack take a mere time of O of 1. And for space complexity, it would be O of n, as we have to push all the opening brackets onto the stack. And so I'm gonna submit the code that I just presented to you, and just one afterthought, I had briefly mentioned about the input string being even and odd number, so we can have a validation to check for that. So we can say if s.length modulus modulus 2 does not equal 0, then we would immediately return false. So what this means is, like, if the input string, if it were divided by 2 and its remainder does not equal 0, which is what the modulus operator is, it's a remainder operator. So if it does not equal 0, that means it's an odd number of input in our string. So that would immediately render it false. And like I had mentioned, having an odd number of input string would invalidate a string, because then that leftover number, the odd parentheses, would not have another parentheses that could account for it and close it off. Anyways, let's run this code, and I'm gonna submit it. Okay, I just wanted to point out that for some reason LeetCode always tends to do this with me, and let me know if it does this to you as well. It gives me a different runtime for the same exact submission from previous time. So let me show you an example of that. So I have this exact same algorithm that I did previously, and I got 100th percentile. But today I got a 40th percentile. So go figure. I don't know why there's a discrepancy between two submissions, but if you know, inform me. Thank you. And please like this video and let me know in the comments what I can do better, if you were able to relate to my explanation, if I can do better in any areas. Your commentary and feedback would be of wealth to me, and much gratitude. And if I can be of help in other videos, other problems that I can help understand, please let me know. And thank you for watching.